Hello, my name is Hassan Lakis. Welcome to this tutorial, which is on differentiating sine and cosine curves. I'll do the sine one because of time, obviously, and then you can do the cosine one and see what happens. I've chosen the advanced mode, and you have to because you need to select radians, the radian mode. Equal aspect, I'll leave that to you to decide. You might get better scales than I have. You need to select a slope plot. It's better when you're plotting graphs. You can have a discussion, pause. Just click anywhere in space, press enter on your keyboard and type in y equals to sine x and pause to ask questions about what the curve would look like, the intersection of the axes, mainly the x-axis really. Okay, in order to differentiate using autograph, differentiate sine x, you select it with the left mouse, go to slope function, and what it's going to do is plot points, draw tangents at different points on the curve, and plot the gradient dy by dx against x, and it'll stop because it's on slope plot, and that's how we prefer to do it when we're showing students. It'll stop at stationary points, and you can simply press the pause key to continue. You can see all the stationary points of inflection and the maximum, minimum. And you can ask them what they think the curve is, and of course it's cos x. Click slow plot to get it to finish quickly. Click anywhere outside and you can see the colors. So y equals to sine x, dy by dx equals to cos x. Great. What we'd like to do next is to double click with the left mouse, the red one, sine x, and let's introduce a constant a multiplying factor. And a is 1 by default. When a is 2, you could ask them what happens to what's 2 sine x in terms of a transformation, what's happened to sine x to get 2 sine x. All those discussions can come in at various points during the work you're doing on autograph. A is 1 by default, so nothing's happened. Select the red one with the left mouse, go to the constant controller, click that, it's ready for action. Let's increase A and observe what happens to the derivative. So at 2, click anywhere outside to see the colors. That's y equals to 2 sine x. What's this curve here? It's y equals to 2 cos x. And increase it further, say to 3. The red one is y equals 3 sine x. And this one, blue one, the derivative dy by dx is 3 cos x. Let's decrease a and go to the negative side. At 0, of course, if a is 0, y is 0, dy by dx is 0. You can ask them that if you want. What happens at minus 1? The red one is y equals negative sine x. The blue one, dy by dx, is negative cos x. Bring that down to minus 2. The red one is y equals negative 2 sine x. What's the derivative? dy by dx is negative 2 cos x. So then what does it mean in terms of the constant a? What effect does it have? If y equals to a sine x, what's dy by dx? It's a cos x. And then you can select animation, select option, animation, negative 3 to 3. You can have different values, depends on your scales. Steps of 0.1, select the animation, bring the animation speed down, click OK. When you play, you can pause at any time, and this is quite dynamic, and that's what autograph is all about. Okay, what I'd now like to do is introduce another constant. So before I do that, I need to go to options, select manual, click OK, change a back to 1, press enter, and we're back to where we were. Click anywhere, double click with the left mouse on the red one, the sine one. Let's introduce b, so it's a sine bx. By default a and b are 1, so nothing will happen. When I select the red one, I can now keep A at 1 and let's change B. And you might want to ask the questions, you might want to discuss transformations of graphs in terms of what B does, what effect it has having a bx to sine x. But what we're more interested in the derivative or the derived function. Okay, so at b equals to 2, the graph, click anywhere to see the colors. The red one is now y equals to sine 2x, remember a is 1. dy by dx is 2 cos, and they might say x, but in fact it's 2 cos 2x. So if you want to confirm that, click anywhere outside in the space, press enter and type in y equals to, press enter in your keyboard, type in y equals to 2 cos 2x, press enter or press OK, and it's gone right on top of it. Now, if I undo that to get rid of the curve, we're back to where we were before. You can now increase b to 3, and if I click anywhere else, you can see the colors. That's y equals to 3 sine x. Sorry, that's y equals to sine 3x. What is the derivative of sine 3x? It's 3 cos 3x. Then you can start thinking about what effect the b has in terms of the derivative. Let's make b negative. At 0, of course, it's still sine 0 is 0. So y equals 0, dy by dx is 0. And if we take b down to negative 1, which is an interesting one, the red one is y equals to sine negative x. And sine negative x, of course, is the same as the negative of sine x. That's why it's a reflection in the x-axis. All these things can be brought in. There's no harm at all. So, if y equals to sine negative x, dy by dx is negative cos negative x. Remember, the angle doesn't change. But in terms of examinations or assessments, we need to tell them that they should simplify that to negative cos x, because the cos of negative x is the same as the cos of x. As you know, it's an even function. Let's decrease b further to minus 2. So the red one is y equals to sine negative 2x. What's dy by dx? It's negative 2 cos negative 2x, which can then be simplified to negative 2 cos 2x. Choose options, animation. Let's go from minus, say, 3 to 3. We are changing b. 0.1. Bring the animation speed down, click OK and play and watch it. And you can pause, of course, at any time and have a discussion. Okay, if I go to options, sorry, before we do that, it's worth then pointing out it's now worth changing b back to 1, change a and change b simultaneously and see what happens in terms of the multiplying factor. So if you go to options, select manual, click OK. We'll keep b at 2, press enter, and we'll make a, we'll keep a at 1. So b is 2, and I'm going to increase a. So the red one at the moment is y equals to sine 2x. Just double check that b is 2. Yes, it is. Increase a to say 1.5. So the red one is y equals to 1.5 sine 2x. What's that blue one? It's y equals to 3 cos 2x. And again, you can just click anywhere in open space, press enter and type in y equals to 3 cos 2x, and it'll go over the blue one. So ask them what's happening in terms of a and b. where did that 3 come from? What happens when we go to a equals to 3? 3 times 2 is 6, remember b is 2, so the red one is y equals to 3 sine 2x. What's the blue one? Y equals to 3 times 2, which is 6, cos 2x. And of course you can go to the negative sign and show them what happens at when a is negative 1. Remember b is true,